Alright, so we're going to go over exponential functions, and that's kind of why I entered that way. You'll see more of that when you start graphing these functions. But for that, let's go over what exponential functions are by definition. So say you had a function, just a general function, and it looked like this. F of x equals a to the x power. This would be considered an exponential function if a is greater than 0. So you can't have any negative a's, and you can't have it be equal to 0, because then it would be a constant function. Also, a cannot be equal to 1. So it can be greater than 0, but it can't be equal to 1. For the same reason, it can't be equal to 0. If this was equal to 1 to any power is always going to be 1, so you're just going to have a constant function rather than an exponential function. It'll make more sense when you start graphing these. In class, we're going to be graphing these. Okay? A is called the base, so if you hear me say the word the base of the function, the base of the exponential function, I'm talking about this A term right here. Some books, they put it as B, but it means the same thing. It's just the base of the function. It's called the base. Make sure you know that. X is the exponent, so if you hear me say changing the exponent, that would be changing this x term up here. Now you guys are used to, whenever you see exponents in functions, x squared, x to the third, x to the fourth, whatever, you're used to that exponent being a fixed number. But now, since we're putting it as x as the input, when you graph it, x can change throughout the number line, okay? And we're going to do more of that when we start graphing these things, so let me know if you have any questions.